Howdy everybody in YouTube land. This video is a little bit different. I'm actually at work right now, so I don't know how much of this I'm going to be able to film, but also the reason why I wanted to do a quick little video like this because I think it's an interesting topic that you don't really see on YouTube. There might be a channel or two out there discussing it, but if not, well, I guess I'll discuss it. But what you're looking at here, I figured I'd start here because it's still too dark outside to do any kind of filming, and it's going to be kind of a mishmash because it's a complete afterthought because this thing's been sitting here for a couple months now, so I don't have any good footage on it. Anyways, so what you're looking at here is the main board out of a road sign, a roadside message sign. You know, like the ones that tow behind a truck and tell you that the road's closing at 8 p.m. or divert traffic or whatever. You know, those roadside sign message centers. Well, I've got one that didn't work, and the text was in the wrong positions on the LED modules in the front of the display. And it's because after countless times through tech support of the company who makes this thing, it's got the wrong board in it, okay? And unfortunately, as expected with most companies like this, they are not on the right to repair advocate. To a degree, you can still buy parts, but that's all you can do. Knowing, according to the manual, when this thing was sold, you could actually buy these two chips and swap them out, okay? Well, you can't anymore. And when you try to ask for it, it's like, I want to try to fix this board myself. I know how to do that. I'm an electronics technician. This is what I've done for a living. They're obviously against it, and then they go without saying that, you know, they're like, oh, it's a safety issue. It's a major safety issue. You can't trust to repair these boards, blah, 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 blah. Because since it's a traffic sign, they consider it a safety issue when you try to repair this board yourself. Which, okay, I can understand where they're coming from if they're talking to the consumer, but they're not talking to the consumer. They're talking to a repair technician that's certified in this stuff. Anyways, I digress. So basically, it's got the wrong board in it. So I contacted the company who owns the sign, and they brought me a board to another sign that's the exact same, and it worked. So this is a good board. So as you can imagine, these two chips here are the firmware chips. One of them is the data memory, and one of them is the actual firmware. And it is a, let's see, it's actually made by Wanco, W-A-N-C-O. PS2 keyboard port for controlling, to log into the terminal to be able to do the message editing and stuff like that. This board was made in 2008, so she's getting up there in age. But got a Xilinx XC series CPLD, actually a 3120. I don't know if that's a CPLD or if that's an FPGA. I'm not entirely certain. But the model number of the sign is WTLMB-07. Yeah, that's correct. That's what's out there. But that is not what's in the board that's out there. So what I did was, what I'm going to do is I'm going to take the programmer that I got a USB programmer, and I'm going to go ahead and just read these chips out and then figure out, you know, save them somewhere. And I'm hoping, because I don't see any other programmable chips on this board, so except for this chip here, but that's programmed from the factory with a specific configuration. So, and I don't mean the factory of Wanco, I mean the factory of Intel. So that's a specific chip that's got the PS2 controller and all that stuff in it. Anyways, I'm going to read those chips out. I'm going to save them under that model number so I have it. Because I'm also going to do that before I put this in here, because these particular message centers use two-way communication with the LED modules. So when you put the board in there, you got to go in and hit the initialize modules button after you sign into the board, which will rewrite the parameters and store new parameters in that chip as well as on all the cards. Because with the other board, it was showing a message, but the rows were off, and it had the wrong matrix size. It was 7x9 instead of 5x7, and it was only 6 wide instead of 8. So I knew there was something wrong, and I figured, because this is the first time I'm actually working on one of these signs, so I figured, okay, well, let me go ahead and initialize the modules and see if it resets everything. Nope, I was wrong. If anything, that made it worse. Now it displays no text at all, and the modules are all random. It's because the board is trying to communicate it at that particular matrix when it's not that matrix, so it's getting confused. But this is the correct board, so I'm going to go ahead and read out the memory and save it, and then get it in the take the board out from the other sign, bring it in here. I've already got those chips saved. I just don't remember the exact model number, but I will save those anyways, and I will rewrite those chips with this firmware, and hopefully it works. I don't want to put this board in there. I could, but this already belongs to another sign, and I don't want to disturb the programming and settings in those chips by firing it up in another board. So I'm going to go ahead and just do that, and then I will start filming outside a little bit when it becomes a little more daylight out, to where I can actually see what the hell I'm doing. Now that you can actually somewhat see out here, still a pretty foggy morning, but this is the sign in question. The board that I need to get to is actually in this cover. And I have no idea if the batteries are still charged. I mean, it's got a solar panel, but you never know. Alrighty then, so pull all this craziness out. Yeah, battery still has some charge. And you can actually turn the board on, but it doesn't do me a bit of good, because I got to pull it out. And the way you get this out, first I got to remove the PS2 connector. The way you get this out is there's 2 screws. There's one right there, and there's one like right back there, and then this whole thing swings down. Now once you take those 2 screws out, it lowers down, and then there's the board that's got to come out. You can see those 2 firmware chips here and here. Now I don't know the administrator password on the other board, but that doesn't matter, because the password's stored in plain text in the firmware, so I can just pull it out of there. There's the solar panel power charge controller. So that means, in theory, if I unplug this, it should disconnect the load. Yeah, it does. So now I can remove this board. And through the magic of video editing, there's the board that I took out of the unit. Because there's the original board, which I decided to already pull the chips and read them, which I peeled that label off so I could figure out what chip number it was. And then here's the second board. So this is the one that's the incorrect one. So what I'm going to do is I'm going to compare the two and make sure there isn't any missing jumpers or anything out of the ordinary that isn't the same between the two. See, this is an older board. It was made in 2005, while that one was made in 2008. So, yeah, we'll see. There's the real-time clock. That's what that battery is for. That's so you can put the time of day up on the screen. So we'll go ahead and get this taken care of, and then we're going to try this thing out. And here's the file, the firmware dump, and there's the password right here. That's the default password. That's also a default password. And this is the backdoor password to get in case someone changes this one. So, yeah. Everything's all programmed, so I'm going to go ahead and get it put back in the unit and see what the hell happens. Alright, board is back in. I still got to put screws in the rear. I just got the one barely in there for testing for now. Let's see what the hell happens. Does it work? Well, alright. Password, administrator. Yay. Alright. Status. Let's see. Display cards. Let's see if anything happens with that. Maybe. Alright, init. See if it does anything. Probably got to turn the power on to the cards. I hear him clicking. Do we have action? Ooh. I think we have something. I think we've got something. Well, I got a U. I'm not sure what that is. I think it's one of the cards is bad, which I didn't know before because I didn't have a board that worked before. So, let's see. Message on sign. All right. Let's see. What do we have? Does it work? Holy crap, it works. EFGH. Oh, I had a module that fell down. Got to replace that. Nice. Well, it's fixed. So, the newer LED signs all have a touch screen. Well, this is an older one. So, if you have an older one of these, well, this is how you fix it if you have the wrong board. You can, if you have another sign, you can take the firmware off of that one, reflash the board that you have in there, and fix it. As so. Alrighty then. Nice. Alright. Well, let's wrap this one up, and I'm going to go inside, and since it is my channel, let's talk about the chips and see what they all are. Alrighty then. Well, since that worked out, we might as well just go ahead and take a look at this board here. To figure out what we have. So, we have a Xilinx XCR3128, which I think is a CPLD. I'm not entirely certain. 16C55, that's a UART chip. The flash memory is just a 29F040 from AMD. Trying to get the better lighting on it. There's two of them. They're both the same. Let's see. 8032. So that's an 8051 microcontroller. Well, 8032, but it's the 8051 instruction set. Very common microcontroller, at least at the time. I don't know if it is now. And that is an N82C42, which is a keyboard controller and a few other little things. And I think that's the SRAM, which is a Cypress Semiconductor 62C, what? 128. Let's see, what do we have over here? Move that little poly fuse out of the way. Can't read it. There's no number on it. That's probably, well, actually, it looks like a diode to me. Yes, that's the reverse protection diode. So if the battery was ever plugged in wrong, it would trigger that poly fuse. That is likely the 5-volt regulator. And these are proprietary to Wanco. They make these. Why they make them as modules and not put them on board, I have no idea. Maybe because they use them in other places. There's the JTAG for the CPLD. There is the real-time clock, which is a what? What is that chip? I don't know if it's a Dallas Semiconductor. This board is conformal coded, so it's really hard to see what it is. Yeah, nothing. Well, I mean, that's the chip for the radar. There's the RS-232 interfaces for the serial. And that's the interface for the power. This goes to the power board, but this also controls the LED modules. So the LCD plugs in here, which goes into the CPLD. And that's pretty much it for this board. Thank you for watching, and please feel free to leave a comment if you have one.